This video introduces assembly basics. Create an assembly to position components, define movement, check for interference, and create a bill of materials. Assembly files contain references to part files and other assemblies. When you open the assembly file, the latest file version is opened from the path defined by the project file. Start an assembly with the required template to define units and other default settings. Use the Place Component command to add components to the assembly. Right-click when you place a component to view the options. It is a good practice to ground at least one component so that it does not move. This provides an anchor for the other components. In this example, I am going to use the right-click context menu and select Place Grounded at Origin. This grounds the component and aligns the component coordinate system with the assembly coordinate system. When you place a component, you can use the context menu to orient about the X, Y, or Z before placing. If you have multiple view windows open, you can use drag and drop from the browser of another file to add components. The option to rotate before placing is not available using this workflow. Use the Joint or Constrain command to position components and define motion. Joint explicitly defines the connection type, position, and motion. When you use the Joint command, be sure to select the object to be moved first and the stationary object second. The joint type is automatically determined by the geometry you select, but you can change the joint type before you accept. The Constrain command offers a deep set of relationship tools, but does not contain explicit connection definitions. You can use both types together to obtain the required results, such as this example using an axis-to-axis constraint to complete the mechanism. Use the Show Sick and Free Move commands to troubleshoot relationships. Both Joint and Constrain can describe a range of motion limits. This example uses joint limits to define the start and end position. Joint limits are accessed from the dialog box. There are two primary workflows used to describe the assembly design process: top-down and bottom-up. In a top-down workflow, the components are designed together, such as this fan designed as a single multi-body part. Moving the end of the part marker demonstrates the workflow used to create this part. When you finish a multi-body part, you can use Make Components to create an assembly file. This toy train is another example of a top-down workflow. It uses a master 2D sketch and sketch blocks to define the size and layout information. You can incorporate mechanism movement in a 2D sketch to determine if components are sized and positioned correctly. Another type of top-down workflow is to create new components in an assembly as shown in this example. Parts you create in an assembly are saved on disk the same as parts you create with a part file template. In a bottom-up workflow, the components are created first and then assembled later. This is often used when the size and shape of a component is known. A typical design incorporates aspects of both top-down and bottom-up workflows. After you create the assembly, drive a joint or constraint to animate your design.